The next is the skin type vacuum packaging machine. So here the product will act as a forming mold. So product is there, it will act as a forming mold. So basically we are using two things. One is the base and another is the top filling. The base may be a tray, a plastic tray or a cardboard we can use. And the product will act as a forming mold. This is the product which will act as a forming mold. The top film is softened before being skin wrapped. The top film will be softened before it is skin wrapped onto the product, and therefore since it gets softened due to the heat that we apply, it do not damage the product. So top film then closely wrapped around the product shrinks and form a seal wherever it comes in, and wherever it comes in contact with the base. So the base may be the tray or the cardboard, and since it is heated, the top film is heated and it gets softened and it gets sealed wherever it comes in contact with the base. So you can see this is the base, wherever it comes in contact it will get sealed. So advantage is that it increases the appearance of the food and it gives a very good effective display. But this is commonly used for high quality expensive product. The disadvantage is difficulty in opening. So we may find it difficult to open the top film, and cost involved. That is the disadvantages of skin type vacuum packaging machine. The next is the deep drawn type vacuum packaging machine. Here we have the lower film, that is A is the lower film, you can see here. It is warmed by the hot plate. So here the B is the hot plate. It is warmed the lower film and it makes more soft and flexible, and it will be drawn into a particular shape. It will be drawn by a particular shape using a vacuum pump, through a vacuum pump. That is, C is the vacuum pump. Here you can see it is drawn to a particular shape. Once it is drawn into a particular shape, the food D, see this is the food D, is loaded in the bag. In this bag it is loaded. Then again the next upper film will come. So the next upper film will become, and it will be sealed here. Okay, it will be sealed here. So the lower film A and the upper film A will be sealed together, and it forms a, and this will take place in a vacuum chamber, and we get a package like this. So this is called as a deep drawn type vacuum packaging machine. So advantages of vacuum packaging. One is it increases the shelf life. So almost 50% to 100% shelf life will be increased when you go for vacuum packaging. The excellent barrier, so it has a very excellent barrier properties. The vacuum package material that we use is having excellent barrier properties. So it helps to prevent the loss of moisture, and thereby it will help to prevent the freezer burn. So when you keep it for long durations in the aerobic packaging, there is a chance for freezer burn. But when you go with the vacuum packaging using a proper barrier materials, the freezer burn conditions can be prevented. Next is it improve the product presentations. So here the bags are clear. There is no space for the fog to come and accumulate. So there is no fog formation. The package will be very clear and transparent. The sealed barrier from the external elements. So it has a very good barrier. So it prevents from the dust, moisture, insects, and other external element that can damage the food materials. It is very quick and effective packaging. In the long run, it will save your money. So coming to the disadvantage of vacuum packaging, one is it is unsuitable for the retail display, especially when it comes to the red meat. So when it comes to the up to the retail display, we can go with the vacuum packaging. But in the display unit, we have to go with the aerobic packaging, because then only it can form the oxymyoglobin, which is the red bloom, we can say, which is attractive for the consumer. Another is it forms irreversible deformation of the product. So if you are using a very soft products, say a very soft, thin dried beef, it can break when you apply this vacuum pressure. So it cannot be used for such products. For example, if you take the chips, the potato chips, if you do vacuum packaging, what happens? Because of the pressure of the vacuum pressure, the chips may leads to the deformity of the chips will take place. So for such product we cannot use the vacuum packaging. Drip loss is a very study shows that drip loss is higher in vacuum packaging than matte packaging. So compared to MAP packaging, vacuum packaging is having more drip loss. However, if you go with the shrink vacuum packaging, the drip loss will be very less. Unsuitable for the meat product that are sensitive to pressure. Example, thin slices of ham or the bacon. So if you make a ham or bacon as a thin slice and then you go for vacuum packaging, what's the problem is that when you want to remove one slice from the another, it is very difficult during the usage time. So that is another issues we can come across the vacuum packaging. That is, we cannot use vacuum packaging for packaging of very thin slices of ham or the bacon, because we find it very difficult to remove one slice from the another when we are putting in usage. So next is the modified atmospheric packaging. It is also called as a MAP. So what is MAP? So MAP, it is nothing but we are modifying the, suppose this is the food materials and this is the package. We are modifying the atmosphere around the package. That is, we remove the atmosphere around the food material inside the package, and we are going to incorporate a new atmosphere. The atmosphere that we incorporate may be a single gas, or we can go with a mixture of gases. Either we'll be using the nitrogen, or we'll be going with a combination of nitrogen, oxygen and carbon dioxide. The best example to understand is the chips, the Lay's chips we can take. In the Lay's chips, it is filled with, we are removed the atmosphere and it is flushed with the nitrogen and it is sealed. So inside the package or around the food inside the package, the atmosphere is changed with the nitrogen. Is it clear? So it's the closure of food products in high gas barrier materials in which the gaseous environment around the food material has been changed to slow down the respiration rate. So it slowed down the respiration rates because we'll be replacing the oxygen or the atmosphere with the nitrogen or carbon dioxide like. Then it reduced the microbial spoilage because we'll be using, if you use the carbon dioxide, which has a very good bacteriostatic effect, it will reduce the bacterial spoilage. It retards the enzymatic spoilage also, because when we remove the oxygen, the enzymatic reactions will also be slowed down. So these are the advantages of going for the MAP packaging. So what are the different gases that is used for modified atmospheric packaging? One is the oxygen. So oxygen, when especially in the case of red meat, we'll be using the oxygen because oxygen will combine with the myoglobin to form oxymyoglobin, which is very much required. Another is it inhibits the obligate anaerobes. Then what is the use of nitrogen in the MAP packaging? Nitrogen is a colorless gas, inert, tasteless gas and low solubility in the water. Since it is having low solubility in the water or in the lipids, the package will not collapse. See, when you fill with the package with the nitrogen, it will have a ballooning effect. So the chips or whatever you put inside the package will not break. That is a ballooning effect we can see. And this nitrogen is mainly used as a filler gas. So we are just removing the atmosphere and we are filling with the nitrogen. So the other reactions like rancidity can be prevented. The microbial growths can be prevented. So that is why it's called as a filler gas. So it displaces the oxygen, so prevent the oxidative rancidity. Third, what is the use of this carbon dioxide that we use in the MAP packaging is that it has a bacteriostatic effect, especially mainly against the gram-positive like Pseudomonas. So this bacteriostatic effect is seen at the concentration of between 20 and 30% in the headspace. If you have this concentration, and the headspace of the package, if you have this concentration, we will be able to destroy or we will be prevent the bacterial growth, especially bacteria, molds, and the fungal growth. The maximum bacterial effect and the storage temperature, to attain the maximum bacterial effect, see that you keep the storage temperature of the modified atmospheric packed meat and meat products at a lower temperature, because at lower temperature the solubility of the carbon dioxide will be increased and its bacteriostatic effect will be increased indirectly. Okay, too much of carbon, but you cannot go, generally we recommend not to go more than 30% carbon dioxide in a package, because it gives it will change the aroma of that product and not only causes it also causes the package to collapse because it is soluble in the water and lipids. So after some days, because of the solubility, the package will start collapsing if you are going for high concentration of carbon dioxide. That is one we normally recommend the low concentration, say up to 30 or 35, we can go. It is not recommended to go beyond 30 in most of the packaging material, in most of the food materials. So what is the difference between the MAP packaging and CAP packaging? MAP itself, there are two types. One is called as a passive MAP packaging and the active MAP packaging. In the food industries, we generally go with the active MAP packaging. So in the we'll see what is the difference between the modified atmospheric packaging and controlled atmospheric packaging. So in the modified atmospheric packaging, initially we will charge with a particular proportion of gases, and after that we will not maintain that pressure. So sometimes it will get absorbed, sometimes there will be leakage. So in the case of controlled atmospheric packaging, the concentration of the gases is maintained throughout the storage process. Up to the end, it will be the concentration. Suppose 20% carbon dioxide means 20% carbon dioxide will be always maintained. Say for example, if you use carbon dioxide, if the carbon dioxide get solubilized in the, or it is get dissolved in the moisture or in the lipids, naturally the carbon dioxide concentration will decrease. So there will be some sensors. These sensors will show that there is a carbon dioxide reduction. So again, the carbon dioxide will be flushed inside that package or in that room. Okay, that is called as controlled atmospheric packaging. So consistent with the expected requirement of the commodity and transportation duration. The technique is superior to the MAP. It is naturally it will be superior to the MAP because we are maintaining concentration throughout up to the last use. Here the lower cost advantage compared to the CAP. Naturally this will be lower because here again and again we have to flush the gases to maintain the concentration. So here precisely gas partial pressures are controlled. So these are the this is just an example of different gases that we can use for chicken. You can go 100% with carbon dioxide, pork 40% or 30 to 40%, rest you can use the nitrogen. In this too, we are not much concerned with oxygen because the color is not that much important in the case of chicken because you know it's a white meat. Then in the case of cured meat, we should not use the oxygen. So oxygen is completely exempted from this usage. So we have to use only the nitrogen and carbon dioxide. So like this, lot of studies has been done and different combinations that have been done. So you can use according to your product requirements. So packaging of the cured meat. In the case of cured meat, the two things are very important. One is the cured flavor and the cured color. The cured color will fade when you expose to the oxygen and the light. And this fading of the cured color is more when there is more light and the oxygen is there together. So generally what we recommend is this: for 2 or 3 days after the packing, you keep it in the dark room so the residual oxygens will be utilized. So you know that normally there will be residual oxygens in any package. So that residual oxygens will be utilized. So the fading of the color, when you expose to the light, the fading of the color will be less. So what is the objectives? Apart from the other requirements of the packaging, the main objectives that is required in the cured meat is it should prevent the fading of the attractive pink cured color, and it should able to maintain the retain cured flavors. It has to retain the flavors and other functions which we already discussed, like preventing the moisture loss, prevent the further microbial contaminations, prevent the textures, etc. So coming to the cured colors, we can see this is myoglobin, purple color, you can say oxymyoglobin, which is a bright red in color, cherry color. When it is in the myoglobins, you can also see it is in the ferrous form, so the color will be like this. Then nitrosyl, when it is cured, nitrosyl myoglobin, you can see this is the color, which is dark red in color. In the case of metmyoglobin, you can see which is not attractive, it just gives a brown color. Nitrosyl hemochromogens, that is a cured color, so you can see it is a cured pink color, you can see. Without curing, and if we cook it out, we get denatured metmyoglobin, again gray brown color, so it is not attractive colors. That is why we go with curing, so it gives a pink red color, which is very attractive. So what are the packaging system that we can follow? One is tray with overwraps. So already we discussed in the fresh meat. Same thing we can follow here also, tray with overwrap. Inside the tray also you can flush with gases. So this is normally we recommend for a short term storage, that is at the display unit. Then string package you can used for the hams and the irregular cuts, cured hams and the cured irregular cuts, we can use the string package also. Vacuum packaging, again you can use for the cured product, we can go with the vacuum packaging. So oxygen is removed. And MAP packaging, okay, modified atmospheric packaging also you can use. So we can go with 100% nitrogen, or you can go with 85 to 90% nitrogen and 10 to 15% carbon dioxide. So another advantage is in the case of when you slice it, suppose this is a ham and you're slicing it small pieces, and when you go with the vacuum packaging, it's very difficult to separate the slices. But in the case of MAP packaging, it ensures the easy removal of the slices at the usage end. Okay, so it helps to remove the slices easily. That is another advantages of going for MAP packaging. So coming to the packaging of the dehydrated meats. So you know that any dried products will absorb the moisture from the atmosphere. For example, if you take a biscuits or if you give the chips, if you keep it at the atmosphere, you know that in the atmosphere there is a lot of moisture. So this moisture will be absorbed and it will lose the crispiness. So any dried product, so you know the dehydrated product, meat products is a dried product. So it has to prevent, objectives is that the packaging material that we use should prevent the moisture absorptions, and it prevents against the oxygen and the light. So it has to prevent the oxidations also. Okay. So what packaging materials and techniques we can use? One is the tin plate cans you can use for packaging of these things. Then we can go with the laminate packs. Okay. Or you can go with the glass bottles. So you can see the gas bottles here. And techniques that we can use is the vacuum packaging we can use. But when you are going with the vacuum packaging, see that it's the product should able to withstand the vacuum pressure that we are going to apply during vacuum. Is it clear? So it should able to withstand, it should not lose its structure. Okay, so vacuum packaging, and you can use it. You do vacuum packaging and then you can put it in a package like this, or you can put it in a small corrugated boxes like. Okay, and we can go with the MAP packaging also. MAP packaging, again, you can flush with nitrogen, 100% nitrogen you can use for dehydrated meat products also. So for coming to the dehydrated products, we can use the tin plate cans, laminates, glass, and the techniques that we can use is the vacuum packaging, MAP packaging, or even in the ordinary laminated package without MAP or vacuum packaging also we can do. So this is how we can do the different packaging for the dehydrated meat products. So thank you very much for listening. If you have any doubt, you can ask. So thank you. Take care. God bless you all.